Do you know what the most expensive survival insurance policy the United States has ever bought? Not an aircraft carrier, not a squadron of stealth fighters, but a ghost that lives where no satellite can track and no camera can reach. The Columbia class, 12 submarines, more than $10 billion each, a projected lifecycle cost of roughly $347 billion. Stand one upright and it rises like a 50-story building. Send it deep and you are dealing with a machine so massive it outweighs the steel and copper of the Statue of Liberty by roughly 90 times, with a submerged displacement around 20,810 tons. For more than 40 years, that job belonged to Ohio. So why replace a legend? How far have Russia and China pushed anti-submarine warfare to the point that the United States now needs a technological marvel designed for one mission: to disappear reliably for decades? And what happens if America slips even one patrol cycle and the deterrence equation starts to drift? In this episode, we are going to break down the most survivable undersea leg of America's nuclear triad. Stay to the very end to see Columbia for what it really is. Not just the largest and most powerful submarine class America has ever built, but the most important one, designed to be the last guarantee that retaliation survives. Let's begin. Chapter 1. Why the Ohio legend is stepping aside, and why America has to pass the crown. After more than 40 years at the core of America's undersea deterrent, the aging kings of the Ohio class are approaching their twilight. Once the ultimate symbol of nuclear deterrence, the hidden sword beneath the sea, the most heavily armed submarine class the United States has ever built, their greatest adversary today is no longer enemy fire. It is time. A submarine's pressure hull does not negotiate. At depth, pressure does not care whether you are a legend or a newcomer. Every patrol is an invisible stress cycle. Metal is compressed, vibrated, stretched, contracted thousands of times in an environment where an error no wider than a human hair is not a maintenance issue. It is permanent disappearance. You can replace computers, you can upgrade radar, you can modernize missiles, but you cannot update structural fatigue in steel. As Ohio ages, maintenance intervals grow tighter and more frequent. And in nuclear deterrence, the real danger is not a weaker submarine. It is a missed patrol cycle. Undersea deterrence does not live on spreadsheets. It lives on presence. There must always be a survivable response waiting beneath the surface. The moment an operational schedule slips even slightly, you create a gap. In strategy, gaps are fatal. That is why the United States must pass the crown. Columbia was not built to be a newer Ohio. It is the solution to a problem Ohio no longer has time to carry. Look at 4 numbers that tell the entire story. Ohio, 14 boats, 24 missile tubes each. Columbia, 12 boats, 16 missile tubes each. At first glance, it appears the United States is scaling down. Fewer submarines, fewer launch tubes. That is the amateur interpretation. The U.S. Navy does not measure strength by tube count. It measures strength by operational days at sea. The difference begins inside the reactor. Ohio-class submarines require a midlife refueling overhaul that can last up to 40 months. Meaning years when that hull cannot deploy for deterrent patrols. Columbia uses a life-of-the-ship reactor core, eliminating the need for midlife refueling. No refueling does not mean no maintenance. It means no multi-year gap tied solely to replacing nuclear fuel. And that is a strategic level difference. 12 Columbia-class boats can sustain at-sea presence equal to, and potentially more stable than, 14 Ohio-class submarines. Fewer hulls, more presence when it matters. Now the reduction from 24 to 16 missile tubes. This is not a sacrifice. It is a strategic trade. The space saved from 8 missile tubes is used to install an electric drive propulsion system. This technology removes a major source of mechanical noise from the drivetrain, maximizing Columbia's stealth profile. We will break down this system in detail in the next chapter. In the new era, 16 tubes an adversary cannot locate are more terrifying than 24 they can track. As of late 2025, USS District of Columbia is more than 50% complete. The program is racing the clock to launch this year and achieve operational status by 2030, precisely as the first Ohio-class submarines begin to retire. Ohio was the crown of an era when the oceans were darker and less instrumented. Columbia is the crown of a new era, one where invisibility must be engineered and purchased through advanced design and technology. Because the ocean of 2026 is being turned into a net. Russia and China do not need to hear you clearly. They only need to increase tracking probability slightly, consistently, persistently, long enough to turn a ghost into a target. What is that net made of? How does it function? And why was Columbia designed to break its probability curve? We will dissect that reality in the next chapter. Chapter 2: The Hunter's Net, and how it turns a ghost into prey. Anti-submarine warfare is not about seeing a submarine. It is about making the submarine no longer certain it is invisible. Russia and China are pursuing one objective: turn the ocean into a space with no gaps, no gray zones, no room for an SSBN to survive on luck. They do not need a perfect detection. They only need to build a tracking chain long enough for probability to do the killing. And that chain begins on the seabed. China calls it the underwater Great Wall. Russia calls it the Harmony System in the Arctic. Different names, same purpose: turn maritime choke points into traps. Here is how it works. You do not need sensors across the entire ocean. You place them where submarines must pass. Straits, continental shelf edges, natural corridors connecting deep water to the open ocean. When an SSBN transits through, it is not visually detected. It is logged. A small anomaly, a disturbance just large enough for the system to register. Something moved through this gateway. From that moment, the hunt is no longer blind search. It becomes tracking. China uses UUVs to shadow. UUVs do not fatigue. They can loiter for days, tow sensors, re-listen, reprocess, and update relative positioning. Russia rotates surface ships, maritime patrol aircraft, and attacks submarines to maintain contact. This is where SSBN survivability begins to erode. You are no longer being chased by a single hunter. You are being handed off from one hunter to the next. If contact weakens, they do not quit. They widen the grid. They queue additional sensors. They feed more data into the system. And when the data set grows dense enough, they stop asking whether something is there. They begin asking where it is. This is where AI changes the game. The ocean is saturated with noise, waves, commercial shipping, geological shifts, marine life, weather. Human operators miss things. Algorithms do not get tired. China has accumulated years of acoustic data, training models to classify extremely subtle signatures, a faint vibration pattern, an unusual frequency band, a thin mechanical whine. They do not need 100% certainty. They need high probability. And once high probability enters the equation, the SSBN loses its most valuable shield, the adversary's doubt. From that point forward, the hunter is not asking if, the hunter is asking where. Localization is the most unforgiving phase, because now they are no longer relying on a single sense. They fuse multiple inputs to compress uncertainty. China is experimenting with ultra-sensitive magnetic detection systems, including squid-based sensors, targeting minute magnetic fluctuations created by large moving metal masses. It will not work everywhere. It will not work all the time. But in certain geographic corridors, under certain conditions, it can be enough to turn invisibility into trackability. At the same time, the surface layer remains active. Radar satellites can detect subtle anomalies on the ocean's surface, transient disturbances, patterns that do not confirm a submarine, but suggest abnormal movement. Research into LiDAR follows the same logic, not penetrating the entire ocean, but exploiting specific shallow water or surface conditions to convert hints into data. When seabed sensors alert, UUV's shadow, AI classifies, and multi-domain sensors compress the search box, the hunt enters its final stage. Termination. The torpedo only enters at the end. But the torpedo is not the most dangerous element. The most dangerous moment is when the target has been compressed into a probability box. A Russian Yasin-class attack submarine or a Chinese ASW platform only needs one sufficiently accurate fix. From there, the rest becomes physics. And this is what makes undersea deterrence fragile. An SSBN is not allowed to fight to prove it is strong. It is allowed only to disappear. The moment Russia or China convinces the world that an SSBN can be tracked long enough, deterrence begins to crack. Because cannot becomes can. And in nuclear strategy, sometimes the word can is enough to alter behavior. This is why Columbia exists. Columbia was not built to carry more missiles. It was built to survive this net, to break probability at every stage, to make detection harder, to fracture tracking, to degrade AI confidence, to prevent localization from closing, and, if necessary, to create escape paths from the probability box through decoys and a supporting UUV ecosystem. Because if the Russian and Chinese net becomes good enough, even a ghost can become prey. And that is Columbia's real war. Not a war of firepower, a war of disappearance. Chapter 3. The Art of Breaking the Net. No matter how sophisticated the Russian and Chinese anti-submarine networks become, they share one fatal weakness. They live on cumulative probability. If you collapse probability at each link in the chain, the entire billion-dollar system turns into a billion-dollar exercise in futility. Columbia was built for that exact mission. Not to be stronger, but to be harder to define. It does not win through a single revolutionary breakthrough. It wins through the art of breaking the chain. First, make the seabed hear only noise. China may seed sensors along strategic choke points. Russia may deploy harmony across critical Arctic corridors. But every sonar network craves one thing: an acoustic signature, a mechanical fingerprint. Older generation submarines like Ohio carry an acoustic liability: the reduction gears. When turbine power passes through massive gears, metal grinds against metal. It does not have to be loud. It only has to be consistent, repetitive. That repetition is exactly what adversary acoustic libraries need, and exactly what their AI prefers. Columbia changes the rules with electric drive propulsion. The reactor generates electricity. That electricity drives the propulsion motor. The reduction gears disappear. The grinding signature disappears with them. The submarine no longer emits a predictable mechanical rhythm for adversaries to catalog. It becomes a whisper blended into ocean flow. When ambient noise swallows signature clarity, the first detection layer in the hunter's net begins to lose fidelity. But Columbia does not just silence the engine, it silences the body. The hull is coated with next-generation anechoic materials, not only to absorb active sonar, but engineered for durability. Because a single patch peeling away can become a perfect AI reference marker. Columbia's invisibility must remain stable over time. It cannot degrade mid-mission. If the seabed still captures a faint clue, the next phase is tracking. This is where geometry matters. Look at the stern. The X-shaped rudder replaces the traditional cruciform layout. It allows finer control at low speeds and optimizes hydrodynamic flow around the hull. In the age of radar satellites, the objective isn't to eliminate all disturbance. The objective is to ensure any disturbance is too ambiguous to support sustained tracking. And when AI attempts to stamp high probability on the contact, Columbia's job is to prevent that assessment from ever hardening. Silence is often misunderstood. Silence is not merely lower volume. Silence is lower identifiability. Columbia avoids emitting consistent, classifiable patterns. No clean mechanical rhythm, no easily labeled frequency repetition. When collected data becomes too noisy and too inconclusive, AI hesitates. And once AI hesitates, the tracking chain weakens. But the net does not hunt with ears alone. It hunts with magnetism. China is exploring ultra-sensitive detection systems, including squid-based sensors designed to measure minute magnetic disturbances created by large moving metal masses. Columbia must blur that magnetic shadow. That is why active degaussing systems are essential, continuously adjusting to ensure the magnetic footprint never sharpens into a reliable identification inside sensitive corridors. And if every defensive layer fails, Columbia still requires a final card: escape from the probability box. This is where decoys and a supporting UUV ecosystem enter the fight. Decoys generate false targets to misdirect torpedoes. UUVs detach, carry deceptive acoustic signatures, and pull the hunt off axis. The hunter must maintain track long enough to close the box. Columbia only needs to break the track once. Once contact is broken, the hunt resets to zero. It does not tear the net apart with brute force. It makes the net collapse under its own uncertainty. No confidence, no decisive data, no final firing solution an adversary dares to trust. But there is a deeper truth, and it is more unsettling. If the United States must build a submarine obsessed with survivability at this level, it means the Russian and Chinese networks have evolved far beyond what most of the world assumes. And this is where we reach the core question of nuclear deterrence. Why does America need a ghost that survives at all costs? Because Columbia's mission is not to fire first. Its mission is to ensure that no one on Earth ever believes they can fire first and survive the consequences. Chapter 4: The Impenetrable Wall. Deep beneath the ocean, in total silence, a Columbia-class submarine does not exist to fight a naval battle. It exists for a colder purpose: to guarantee that no matter how precisely an adversary strikes the United States, the cost will still be unacceptable. That is the logic of second strike. In deterrence strategy, you do not need to fire first to prevail. You only need to establish certainty in the adversary's mind. If they launch at 8 a.m., within minutes, their own state faces catastrophic retaliation. Once that certainty exists, a first strike becomes self-destruction. So why does the United States maintain submarines, bombers, and land-based missiles? Why not consolidate into a single system? The answer is the nuclear triad. The triad is not simply 3 categories of weapons. It is an unsolvable strategic problem for anyone considering an attack. The first leg is land-based. Intercontinental ballistic missiles in hardened silos across the American West. In strategic terms, they are often called the nuclear sponge, because to eliminate them, an adversary must launch a massive number of warheads onto US territory. An attack on that scale cannot be concealed. The moment early warning radar detects the inbound salvo, the United States retains sufficient time to launch its own missiles before impact. Strike the silos, and you trigger immediate retaliation. The second leg is the bomber force. Aircraft such as the B-52 and the B-21 Raider. Unlike ballistic missiles, bombers are recallable. They can launch as a signal and stand down if escalation stops. More importantly, they are mobile. With early warning, the fleet disperses. Once airborne, they become distributed launch platforms that cannot be destroyed in a single blow. And the third leg, the most survivable, is the SSBN beneath the sea. Together, the 3 legs create a time paradox for any attacker. No adversary can eliminate all 3 simultaneously. If they attempt a surprise strike on air bases and command centers, their ballistic missiles still require flight time. That window allows land-based ICBMs to detect and launch. If they attempt to neutralize the ICBM force first, detonations and warning systems trigger bomber dispersal and submarine deep dive procedures. There is no perfect sequence, no perfect timing, no scenario in which all 3 legs disappear at once. At least one survives. And among the 3, the Columbia-class submarine is the most difficult to eliminate with certainty. You can map silo fields in Montana. You can identify air bases in Missouri. You cannot map a moving ocean. Columbia is the strategic variable. It has no fixed coordinates. It turns the ocean itself into a launch platform. A single surviving Columbia, just one, carries 16 Trident II D5 submarine-launched ballistic missiles. The Trident II D5 is an intercontinental range SLBM, capable of carrying multiple independently targetable re-entry vehicles. One missile can deliver multiple warheads against multiple targets. That single surviving hull renders any first strike plan strategically unstable. No national leader will risk the survival of their state on the assumption that a hidden submarine has been successfully eliminated. That is why Columbia is more than a submarine. It is the final insurance policy of the United States. It ensures that retaliation remains permanently in the equation. 3 legs, land, air, sea, lock an adversary into paralysis. The ICBMs complicate the math. The bombers provide flexibility. Columbia eliminates temptation. Ohio became legendary because its missiles never needed to be launched. Columbia carries an even more demanding mission. According to current U.S. Navy planning, the Columbia class is expected to operate into the 2080s. So what does a deterrent platform designed to survive into that future require? That is where we go next. Chapter 5. An open platform for the War of 2080. When USS District of Columbia enters service, it is not built for a decade. It is built for a strategic era. Between now and 2080, the world will change multiple times. That is why Columbia was not designed as a fixed configuration machine. It was designed as an open architecture platform capable of upgrades, modular swaps, and absorbing emerging technologies without compromising its core identity: undersea nuclear deterrence. The most significant future shift lies in firepower. Trident remains the backbone of strategic deterrence, but as missile defenses grow denser and decision timelines shrink, the United States is opening the path toward a new capability branch: ultra-fast conventional strike through hypersonic weapons. The most prominent concept is Conventional Prompt Strike, CPS. CPS employs a hypersonic glide vehicle, a payload that separates and glides through the upper atmosphere at speeds exceeding Mach 5, maneuvering unpredictably compared to traditional ballistic trajectories. Its purpose is not spectacle. Its purpose is to compress adversary reaction time and destabilize the mathematics of interception. Columbia holds a critical architectural advantage. Its missile compartment was built with modular flexibility. Large diameter launch tubes originally configured for Trident could, by design, adapt to alternative payload configurations should the Navy pursue future mission shifts. To be clear, nuclear deterrence remains the primary mission, but Columbia's design ensures it is not locked into a single capability in a rapidly evolving strategic environment. The future is not only about weapons, it is also about energy and electrical architecture. Electric drive propulsion was not adopted solely for acoustic stealth. It creates a high-capacity, stable, and flexible electrical backbone, a foundation that older submarine generations could not realistically support. One long-term developmental pathway under discussion involves directed energy systems, such as lasers, as future experimental capabilities. Not to fire through the ocean, but to provide limited defensive or sensor disruption options near the surface, in narrow scenarios involving UAVs, reconnaissance aircraft, or electro-optical surveillance. Lasers do not consume ammunition, they consume power. Columbia has power. Next comes hull and sensing architecture. The future is not simply better sonar. The future is a hull that listens. Smart skin concepts aim to embed sensors directly into structural surfaces, expanding acoustic aperture and increasing sensitivity to pressure variations, vibration signatures, and background noise shifts. In parallel, advanced biofouling-resistant coatings, inspired by shark skin hydrodynamics, are being studied to maintain stable flow characteristics over time, reducing drag and minimizing signature drift. But more sensors do not automatically translate to understanding. You need cognition. That is where artificial intelligence enters. Cognitive sonar represents a development path in which machine learning autonomously filters noise, classifies contacts, and detects extremely weak signatures within an increasingly complex acoustic environment. AI does not fatigue, it does not lose focus, and it excels at the one task humans struggle with most: listening for hours to extract a signal barely distinguishable from background noise. And this is where the 2080 paradigm becomes decisive. Columbia will not operate as a solitary submarine. It will function as a node within an underwater ecosystem. In Chapter 3, UUVs were discussed as tools for breaking pursuit.
In the future, they evolve beyond decoys or tactical assets. They become distributed sensing layers, mobile nodes operating ahead of, alongside, and beyond Columbia's organic acoustic range. Instead of a single submarine listening in isolation, Columbia can operate as a submerged command node, surrounded by rotating sensor platforms, extending persistence and expanding the acoustic picture over time. If adversaries network their hunt, the United States must network survivability. Managing such an ecosystem introduces a new challenge. The question is no longer whether communication exists. The question is whether communication is fast enough, secure enough, and high bandwidth enough to share sonar data and coordinate formations while preserving acoustic discipline. That is why high bandwidth underwater communication concepts are under research, including blue-green laser technologies under specific environmental conditions, not to turn the ocean into Wi-Fi, but to provide just enough connectivity to coordinate a submerged sensor network without sacrificing survivability. In short, Columbia is not an Ohio with new paint. It is a platform engineered to evolve. From modular architecture and electrical capacity to advanced sensor integration, AI-enabled sonar, and distributed UUV ecosystems, all directed toward one objective. No matter how adversaries hunt in 2080, something must still exist beneath the ocean that they cannot reduce to a confirmed target. With Columbia, victory is not measured by missiles launched. Victory is measured by a full service life completed in silence, without anyone ever knowing where it operated. That is the paradox of nuclear deterrence. We build the most survivable weapon ever conceived, so that no one ever dares to test whether it works. Future war tech. The war never stops evolving. Neither do we.